Hello everyone, today I am gonna reveal my session that was happened in a short course titled AI and Cybersecurity Foundation and Program. As it was a paid short course, I will not discuss it comprehensively but give you a success overview of the session. It was organized by the Department of Electrical and Electronics Engineering of Penny University, one of the founding and leading department of the university. I am on 24th October of 2025, the very beginning day of the two-day short course. It's me, Tanvir Hussain. I'm working in the Department of Electrical and Electronics Engineering, Penn University, as a lecturer. My research interests include several topics are given here. Here is my contact information also. Feel free to connect me regarding your any query. I will try my best to respond as soon as possible. Outline of my session. It is divided into two sections. In first sections, I will briefly describe the historical background, applications, ethical uses, and ongoing abuse of artificial intelligence. Then I will discuss key materials of machine learning and deep learning. Here I will show you the dataset classification of learning approach, different popular programming language and development IDEs, like this in Python and popular machine learning and deep learning algorithms. In the second section, I will demonstrate few hands-on projects on machine learning and deep learning for math and physics to programming model implementation. The objective of the session at some point is to provide you with the key insight of artificial intelligence, historic timeline in developing AI step by step. Then some ethics on the application of AI and some abuse ongoing. In addition, it also includes understanding dataset learning approach and various AI development environment and materials. And finally, to show you some hands-on demonstration. Hope that after successfully completing these sessions, you should be prepared for interpret the fundamental concept of AI to save you and your society from the abuse of AI. Aware of the ethical use of AI and moreover, you are expected to construct dataset and recognize appropriate machine learning and deep learning model for the real world based data. Then you should develop your own machine learning models or deep learning models using the sophisticated concept of math and physics. Let's jump to our first topic of first part 1.1 artificial intelligence origin and scope. Historical background of AI. Look at the picture. It shows a snapshot of the attendee of the Dartmouth conference. It includes notable persons such as Marvin Minsky, Nathaniel Rochester, and Claude Shannon. The Dartmouth conference is often considered the birthplace of AI by most researchers. Then, in 1956, the term artificial intelligence was first coined by John McCarthy. A historic timeline of artificial intelligence highlighting key milestone researchers and technologies breakthroughs is shown in this picture. Let's briefly explore it step by step. Macro and Peace in 1943 introduced the first mathematical models of an artificial neuron, laying the groundwork for neural networks. After the Dharma conference, AI captured the imagination of researchers, government, and public when perceptron was introduced by Rosenblatt in 1957, the early neural network model that could learn weight. It triggered the first golden age from 1960 to 1970. In addition, in 1959, Udo Hope developed Adaline, which include linear model for adaptive learning. Okay. Minky and Puppet reveal actual problem that perceptron couldn't solve nonlinear problem like XOR. This criticism leads to the first dark age of from 1970 to 1985. Then hardware was weak, dataset small, and training algorithms insufficient. Government cut funding, especially in UK and US. Neural networks were abundant, and instead symbolic AI or rule-based system dominated. Second golden age, which was long from 1955 to 1995, was triggered by the invention of back propagation by Milton Ito. It enabled training of multilinear neural networks. Real applications such as handwriting, digit recognition, speech processing shows potential. In 1995, after invention of support vector machine, it became popular for pattern recognition. While neural networks were struggling, neural networks were seen as hard to train and prone to overfitting. Support vector machines and other statistical learning methods outperform neural networks. As a result, the industry focused on simpler, more explainable models. Neural networks were mostly sidelined in research and second darkest from 1995 to 25 with the start. And literally from 2010, the revolution of deep learning started, which is known as the third golden age, is still present. Many AI models have been developing gradually from then, such as AlexNet at 2012, GN at 2014, Transformer model at 2017, GPT-3 at 2020, ChatGPT at 2022, and GPT-4 at 2023, and finally Sora at 2024. Alright. Although Hilton proposed a backpropagation in 1986, which led to the revolution of AI, they were awarded Nobel Prize in 2024. It seems it's matter of very hard. Don't worry, I'm gonna just make it easier. Definition of AI. We can say a machine, a robot, for example, a artificial intelligence, if it has these three main characteristics. Classification of AI. Artificial intelligence or AI can be classified mainly into two ways. One of them is based on capability, another one is based on functionality. This Venn diagram shows the interconnections of AI, ML, and PL. Now look at the diagram. It shows the workflow of machine learning. Using a machine learning algorithm, we train the data, which provides the models, and we test the model by another data if the model predicts find its life, and otherwise lose life. Deep learning is structured by artificial neuron, which is nothing but a variable which can store a number. You should have to have some knowledge of math, physics, graph plot, and programming knowledge for learning AI. These are mostly covered in your undergraduate program. There are many applications of AI in our daily life, such as healthcare and diagnostics, finance and e-commerce, transportation and autonomous vehicle system, industry and manufacturing process, education, entertainment and media, security and surveillance system, agriculture and farming, and more complex task engine. Okay, you may know a team of students from search had developed a search engine in 2013 named as Prerequisite, but unfortunately it was shut down in 2021. Actually, I don't know what the reason. This chart shows the top 10 countries' budget allocations in 2025 for AI. We see United States occupies the three-quarters of the circle approximately, but about 471 billion USD. Then China and UK, India also has a budget of 11 billion USD, but Bangladesh government should focus much here. Now I will discuss some ethics in AI. AI must have transparency, fairness and non-discrimination, accountability, privacy and data protection, also environmental responsibility. I will also aware of you abuse of AI ongoing. For example, misinformation, violence of privacy, illegal surveillance, AI-driven discrimination, autonomous weapons. AI-mediated cybercrime, fake review, manipulative data and algorithm, identity theft, and so on. So on. Our topic 1.1 has been covered here apparently. Now concentrate on second topic 1.2 tool of AI, machine learning to deep learning. Dataset. Dataset is a structured collection of data which can be text, image, audio, etc. The table shows some row of example datasets where age, gender, and income is independent features and passes is the dependent features. There are five classes of learning approach: supervised, unsupervised, semi-supervised reinforcement, and self-supervised learning, which is still now emerging. Some popular programming language and their advantage and disadvantage: C++, Java, Julie, MATLAB. Here, some popular development environment: Python, VS Code, Some popular package for AI, data handling, visualization, some for machine learning, algorithm models, some for machine learning libraries or package, and for deep learning packages, ESPN MaxNet. Now I would like to familiarize you with some ML models, also ML model, some DL model, and also some DL model. Alright, we are about to our more important part. Second part of the session, I will demonstrate three fundamental machine learning hands-on projects and four fundamental deep learning hands-on projects here. Let's begin with machine learning. Before building the programming model, we will discuss the physics and math behind the model. Navigate. At first, we navigate to the linear regression. It actually saying a linear model as you see in the picture. For this, we have need a loss or cost function. We have to find the global minima of the cost function. We'll use gradient descent algorithm here for this. A numerical calculation of gradient descent is given here. Okay, it is the first iteration, second iteration, third iteration, fourth iteration, fifth iteration. And here it is clear this is how gradient descent algorithm comes. Loss function in three-dimensional coordinate systems and focus on the global minima. Train model for the global minima. Some validation metric indicates how performs your model do. Some methods are given here. Also validation methods. This is California housing dataset that we will use in our model. For simple univariate linear regression model, we will consider one independent features and one dependent feature. Here the descriptions of the dataset. Okay, now let's see the code in Jupyter Notebook. Open in the Content Navigator. It contains initialize the notebook here. Yeah, to found easily. Launch it. First, let's have one tablet for short course on AI Cybersecurity Foundation and Frontline, which is organized by Department of Electrical and Electronics Engineering Department of our University. Hands-on Project 1. It is Univariate linear regression using California housing dataset, and here are some outcomes after understanding this code. This is me, the about of instructors and disclaimer. This code is part of my personal project and may be shared for educational purpose only with permission. And we start from here and run this cell and input our necessary packages and load dataset. We two rows of dataset and we will select one independent feature and one dependent feature and split the dataset into train and test and plot scatters and so we have to see the data point and then initialize our parameters. Okay, now here we have developed our model using the concept and equations of math and physics. And this is the final weighted bias and this is our linear model and it is for validation and now we will see how much better our model is. It is R squared value which is 0.01. That means our model is not good enough for one independent variable. Okay, this is lost curve. Okay, I hope you understand this code and now I would like to open my second hands-on And this is univariate linear regression using SciKit-learn package. Here are the outcome and instructor disclaimer, and starting from here, input like this, load dataset, and we also uh, we also consider one independent feature and one dependent feature. And in this case, we use scikit-learn packages, which gives a built-in model function, and we have used this function here. We didn't make any function here. We just import package from scikit-learn and uses the scikit-learn fit function for linear regression. Okay, run this cell and final model. And edit. Okay, now this is the evaluation method, and R square value is 0.13, which is approximately same as found in our first hands-on project, which will use our custom linear regression model. We can test it here, and R square model is 0.10 and here 0.13, almost close. Now plot the regression model and we can predict some value here. Okay, I hope you now understand how to use a package to train a machine learning model and how you can develop your own model by using physics and math. I'll come back here again, and this is another class of linear regression. Multivariate linear regression is approximate a hyperplane over the data point. Let's see it in Jupyter Notebook again, and it is the hands-on project number 3, and we start from here and load our required packages and load dataset, and we consider all the features, independent features and one dependent features. Put it with scikit-learn model, put it, and let's see. Okay, here the R square score is improved. Okay, then we plot to the plot, and let's see the visualization of hyperplane. Mm. In this case, we use group lecture only. Okay, this is our approximate hyperplane as we have seen it here. Okay, so let's now move towards the hands-on and demonstration of deep learning. Again, we will also first understand the math and physics of deep neural network. Concentrate this slide. This is a perceptron model, which is use unit step function in activation. Formally, we can define it. It is a variable that can store a binary number. And try to understand how perceptron works as a linear classifier. Implement NAND gate using perceptron. We know that NAND is a universal logic gate by which we can make the fundamental logic gate such as NOT or AND, and I left it for you and try it at your side. This is multi-layer perceptron network which approximates this closed region enclosed by four lines, this colored region. Here some probable approximation case without using bias. As you see in some particular case without bias, perceptron cannot approximate correctly. And this is how bias manipulate network for perfect approximation. Now one step forward to artificial neural. The difference is in the activation function. It can include a non-linear function like sigmoid, rectified linear unit, hyperbolic 10, etc. Let's see the sigmoid and value function curve. Definition of neural network. It's the systems of interconnected neurons which has one input, one output layer and many hidden layers. At first, let's see how neural network works. Suppose a 4-pixel RGB camera. If we consider green color 1, red color -1 and blue for 0, we have these 8 possible patterns to capture. Label each pattern with 1 hot level encoding. Assume this trained network, neural network, and this clearly show how input pictures recognize in output. This is a simple neural network illustrating the forward propagation, loss function, and back propagation. Some calculation of back propagation also here. Cost optimization using gradient descent algorithm. Alright, let's deepen into a little bit deep neural network. It is the forward propagation, the network. Understanding the vector and matrix notation is important here because we have to use two, three, or more dimensional array or vector or matrix while coding. Consider TK are the two output. So we will follow backpropagation for the approximation. Here also some backpropagation calculation. The whole thing in matrix and vector form. Extend it here, and finally this is the open called hello world example of deep learning and written digit recognition using MNIST dataset. Here are some features of the dataset. Each digit labeled accordingly. Here are also some descriptions of the MNIST dataset. An image of dataset is fed into a neural network model. Network should be trained as these for recognizing digit 3 if input digit is 3. Now let's get jump to the Jupyter notebook again. Do not let and then I go to DL and click on first cancel for it. And this is also a part of short course on AI and cybersecurity foundation and frontline. Project 1, forward and back propagation of a simple neural network. Review learning outcome, and instructor is also here high. Listed from here and input necessary like this, and define activation functions, regular function, accuracy calculation, and uh, make a dummy data set simple agile like that. This matters to end for demonstration. Okay, network parameters, and initially we take learning rate 0.1 and we assign 2000 run training loop, and after 2000 epochs the accuracy is 100%. Okay, now see the result and final parameters, and plot NOC curve and plot the accuracy curve. This is just simple. Um, we I would like to show you a little bit deeper neural network, basic neural network model. Project 22 is okay, and this is me again, and run it, define feedback function and network configuration. And this is a dummy dataset we created randomly, and forward propagation, loss function, backward propagation, accuracy computation, and restart training loop. After 1,000 inputs, we found accuracy approximately 100%. Plot and versus input chart and plot the accuracy chart. And now let me show you the final answer for training. Training the value in outputs is 1.015 and target value that was assumed here. This is the target value. Okay, let's compare this. This is approximately 1. Okay, and this is approximately 0, and this is approximately 0.5, and this is approximately 1, and so on. And this is not very bad or not so good, and we should match these two target variables and not change value. Now let's move and on to the page, and here we develop a class for general neural network model. And this is neural, this is learning outcome, and important features are given, and we will put according to this feature. This is new again, and run this thing and define activation function, and here is our general class. Run this one. Okay, now let's get an example using our own class, and we again select a dummy dataset, repeat our model after 5,000 report accuracy is approximately 100%. Plot the loss curve and then plot accuracy curve, and let me show you what is the final range value in the output. 1.09, and it is 1, and it is 0, approximately 0 and 0, and it is close to 1, and it is close to 0. Okay, I hope you have understood. Okay. And now we will show our hello world example of deep learning model. And sample the concept. Hello world example of deep learning. Right. Learning outcome. Let's run this code from here, and load any dataset, and some pre-processing. It shows the image shapes and event shapes. Let's randomly plot a digit with level. Initialize some parameters and set our training loop. Let's see what happens. This is one input and accuracy is 86.33 and NSO is 0.22. The second input accuracy is 92.50 and after 3 the scope accuracy is 23.51 constraint. Okay, now we'll test our model. Okay. This running. Okay. And I have to give the number here and it is between 0 to 59,999. Let's say I randomly source number 20. And what happens? Oh, it is predict 4 and we can see this is also clear. Our model works right. So I hope that you have understand the basics of this programming. Back to our presentation, and this is acknowledgement. I am really thankful to those whose equations, theories, concepts presented in various scientific papers and publications are used in this presentation. I also thankfully recognize the use of part of the text, image, code, or thing, or from publicly available platforms. I express gratitude to all the responsible persons who have shared their knowledge and resources for academic and learning purposes. Finally, thank you for listening to me, and hopefully you will stay tuned until next time. Bye bye.